Hi there, welcome back. Well, the magic of YouTube videos is that you see one in a series and nothing's working. And the next one, everything's working fine. Our radio's back.
Asegura que una prórroga larga solo se concedería. Pero esa teoría existe.
So what happened? Well, quite a lot actually. And I'm going to have to tell you because, like a real dickhead, I lost a lot of the footage. And the reason I did that is I was pausing between shooting and working on here. And what was happening is I was actually shooting the intervals between the shots that I wanted to show. So I had the pause and play or record reversed. It was a total mess, and I decided to scrap that whole, it was actually quite a long bloody video. Like an idiot, I went and put it all in one instead of doing small clips. Anyway, live and learn. So, what has happened since we last met? Well, if you recall, in the last scene, in the last video, we had no radio. We had the amplifier working, but we had absolutely no radio. And the reason for that was actually not twofold, it was threefold, I believe, and I'll explain what happened. My thoughts on why the radio wasn't coming through was that it had nothing to do with the switching over here, because it was the same symptom for all the bands. And that means it can't be, you know, the likelihood of every single one of these tuned circuits going off is very, very small. So you had to look at this thing logically. And the way I did that was I went to, I know the preamp and power amp is working. That is that guy there and that guy there. So I went further back to just before, well, there we go. That one in the middle is the IF amplifier. That's the EF41. And I suspected one of the tubes was gone. So I don't actually have spares of these tubes. These are not particularly normal. These are actually prior to the era of the major influx of German radios that I've repaired. So I have spares of things like ECH81s and EF89s and so on, but I really didn't have spares of an EF41. And I figured that one might be dead, but this thing has got two. So I went to the first one, which was up here, and I took that guy out and I put it in there. And I actually, this thing here, this first one, is an RF amplifier. So this takes the first tuned circuit, amplifies that signal after it's been tuned by the front end, and then passes it on to the mixer oscillator, which is the next tube, which is that guy over there. Now that thing takes the amplified but tuned input signal, let's say 1 megahertz, for example, if that's what you're tuning to. It creates, through the oscillation function of that tube, a 1.46, if it's 460 kilohertz IF. It creates that IF frequency, rather that oscillator frequency. It produces it in the tube and it mixes it with the 1 meg coming in, and one of the things you get out is 460 kilohertz, the IF frequency modulated to the input signal in the modulation that comes in the input signal. So I figured, okay, let's bypass that guy, the first one, put a piece of wire to the input of that mixer. In other words, pretend we have no RF amplifier and see if we get something. And we started getting quite a bit of noise, really nasty noise, but it was radio and I could tune to some of the stronger stations. So I figured, okay, maybe it's not that tube or that tube. Maybe it's that tube. So then I had a problem. I didn't have one of those tubes. So actually, I went so far as to take a EF89, which is very similar to the EF41, although the EF89 is different pinouts, and even the number of pins is different. It's got 9 pins as opposed to 8. But I wired it remotely without that tube in place and replaced the function of that tube with the EF89. Don't take notes, this was stupid, but I'm just telling you what I did. And I didn't get any joy. And then I remembered the first rule, check the voltages. So I checked the voltages, and I found that the screen grid voltage of that thing was dead. And therefore I went back and checked some of the resistors that I'd marked as being okay, and I found a guy down here that was completely open. Replaced that, and suddenly my screen grid had voltage, and suddenly the radio was starting to work. Although it did make one hell of a lot of noise. So the next stage was to figure out why this thing was so bloody noisy. It was tuning, but it was really, really bad. And I remembered from the first video that those 2 lines that we had that weren't findable on the radio. They're in the schematic, but I couldn't find them. And I tried to figure out, it was, again, the description of stupidity, what the hell they did. And they're obviously the AGC, the automatic gain control, signal producers. So from the detected tube, from where are we? That guy there. One of the things that does, one of the diodes does the detection, and the other one produces an AGC voltage, which is negative voltage proportional to the strength of the signal, which in turn then has to get fed back to the grids of the other tubes to adjust the gain if the signal is very high. And then I realized there's one part of this radio that I hadn't checked, and that part was actually inside those guys, inside the IF cans. Now, they're pretty big IF cans for a simple radio, so I decided to open it up. And I found that that little 30 picofarad capacitor and the 1 megahertz, 1 mega ohm resistor that I couldn't find on the radio was actually in there. So that circuit was working fine. However, there was a cock-up with this guy here, this resistor here, which is the one that's going to the Magic Eye tube. It was soldered in the wrong place. It was actually soldered down there as opposed to there, where it is now in the middle of the screen. And that thing was creating all sorts of oscillations and noise. The minute I changed that, this whole thing came back to life. And it actually sounds very good. Now, lessons learned, and that's what this thing's all about, actually. Good thing I don't do this as a profession. I'd be the poorest bloody techie in the world. This is a hobby. Lessons learned. Don't skip components when you're checking the bloody schematic. I actually put the schematic in a PDF, and I put a layer on it and color it in green and red and all that jazz, and then I forgot the one resistor that made all the difference. That guy over there. It's a 100K resistor, and that made all the difference. I also forgot, or rather I try to skip over that you should actually test for voltages on all the pertinent points on your tubes, because if you don't have the right voltages there, or you don't have any voltage at all, you're not going to get any joy. So yeah, radio's working. Now, just figuring out the IF. So here we have the pertinent section where the missing resistor was found. So this thing here, this screen grid, grid 2, is fed through this 100K resistor, and that just wasn't there. So it wasn't coming from the second B+, okay? So that was replaced and this thing started functioning. Now this thing takes the input signal. You have the antenna signal coming in here. It comes down here, down here, down here, down here, and through all this switching, which is on the piano keys, and the function of this gang of the tuning capacitor, what you get coming up here into this 100 picofarad capacitor is a tuned front end. So let's say you put it on medium wave, the pertinent tuned circuits are chosen here, and you mess with this capacitor till you're on 1 megahertz. You are filtering that 1 megahertz signal coming from here, through here, into the front, into the grid of this EF41. That amplifies it, takes it through there, and then it goes into the front, into the grid of your ECH42. The ECH42 is going to take that input signal and mix it with this one coming from down here, which is the oscillator circuitry, which again, if you've chosen medium wave, it's on medium wave, it's chosen the medium wave tank circuit, and with the effect of that gang of the capacitor, if you see it comes up here, the effect of that gang of that capacitor, it tunes to the input frequency plus IF frequency, so 1460 kilohertz in our example. The result is a mixing action and amplification here, and you get coming out of this anode through there into the first IF section here of the IF transformer. You get various frequencies, including a modulated 460 kilohertz IF frequency, if that's your IF frequency, okay? You tune that tank, those two circuits, the IF transformer, to get only the 460, the IF frequency coming through, which goes back into there, through that EF41, which is the IF amplifier. It amplifies it, signal comes up here, and it gets filtered again through that second IF transformer. The result is then out of here, goes in there to that diode, which is the detector diode. And the detector diode, the result of the detection would be audio from there. So I've missed something here because the cat's bugging me. The point is, you've chosen at this point that you want your RF signal to go through, which is through that switch over there. You remember we had pickup and radio. You've chosen radio, that goes in there and it gets amplified through the triode. The triode amplification stage here sends the preamplified signal through there to your output amplifier, to your power amplifier. So the problem was there were a few things missing. This capacitor up here I couldn't find, and that resistor down here I couldn't find. And as it happens, these guys, this one and that one, went inside the can of this IF transformer, and the wiring was perfectly aligned to what is there. There was one mistake, and that is that the signal going to the grid of the Magic Eye, that 1 meg resistor, was actually going to the top there as opposed to going to the bottom there. That signal there, that diode there, is producing your AGC voltage, which comes out of here. It's a negative voltage. It feeds the Magic Eye. It goes through here and it feeds that grid through that transformer. So up there, it goes along here and it feeds that grid directly. And it also goes one step further along here and feeds that grid. So the AGC is this line here. And that was the one, that resistor at the front, this one, was the one that was producing absolutely no signal here. And once we had that thing working, that cock up here was the one that was producing all the oscillations. Now I have adjusted, I've messed with the IF. I'll show you what I did exactly, and I'm going to adjust it to 460 because I believe it is 460. I think it's actually at 465 or so at the moment, but I'll show you that, how you actually figure out where you are on your IF, as long as you can hear the tone going through. If you can't hear it, you've got a problem, but if you can hear it, then you can adjust it for peak, and it's actually quite simple. But let's do that, and let's align this to the 460 IF. Just one thing, this IF can over here has got two transformers, two coils in there with lugs, two cores with lugs. Is that it? Yeah. And you tune them, and they're actually quite easily accessible because sometimes you have one at the bottom, one at the top of the radio. This is not the case. This is just two coils, and they go right through from bottom to top, one on each side, and you can adjust it either from the top or from the bottom, and therefore you don't have to flip the radio around all the time when you want to adjust it. So it's actually quite easy. And I've opened it up and you can see the way it's wired there. There's a lot of space in there as opposed to some of the dual ones. You know, when you've got FM as well, you've got the FM coils and the AM. So it gets a lot more complex, but this is actually quite simple and easy to operate. So I'll show you now. We're going to feed a 460 kilohertz IF signal, modulated signal, and see if the IF is set correctly. Now, the place I'm going to feed the IF signal to is actually here. I'm going to feed it to the grid of this mixer oscillator. So I'm going to feed it into here because we don't really need to worry about the IF going through that tube there. That's just an RF amplifier. It'll amplify anything you put in the front, given a certain bandwidth. But let's take it from this point and feed the IF, the 460 kilohertz, into here. And then we'll tune this transformer, and it then goes into there, and we tune that transformer. And how do we know what we're peaking? Well, we're going to take this speaker, we're going to put a dummy load on it, and we're going to look at the wave coming through the scope. So what we have right now is a 460 kilohertz carrier. I've set it to 2 millivolts. I believe the minimum is 1.4 millivolts RMS on there. I've got this thing modulated, 30% modulation, with a 600 hertz signal, 460 kilohertz. Now that comes out of there and it goes into a adjustable attenuator. At the moment it's maximum attenuation. This thing is 6, 12 and 18 dBs. I've got a total of 30 dB attenuation, 36 dB attenuation on here. There's an AC coupling in there, so we don't have to worry about DC voltage at this end going back into the signal generator. That signal is fed to the grid of that tube, the ECH41. We'll set this to medium wave, put this around the middle, say 1 megahertz. We have the speaker connection replaced with a 5.6 ohm dummy load, and the oscilloscope is across the dummy load resistor. Now we'll just see what we get on the scope. Okay, well, got the volume on max, and I don't see much on there. Now, I could go down. Maybe it's there, don't think so. But I have 36 dB on here, so if I take, okay, that makes a hell of a difference. Drop the attenuation, it gets better. The signal was just far too low coming in. Let me drop the attenuation. Whoa. Okay. I've just got 6 dB of attenuation on there at 460 kilohertz. Now, that's reading 171 millivolts peak to RMS. I have the acquiring on some averaging just so we can get a more distinctive, more visible sine wave on there. Now, what I'm going to do is, it's on 460 kilohertz. I'm going to go down and then up just to see if this thing's peaked somewhere else, okay? So if I go to 459, 458, disappears. 458, 459, 460, 461, whoops. Okay, 461. That was 462, I beg your pardon. 463, 464, 465. 65, sorry, 66, 67, 468. I'm going to go down again. 8, 7, 6, 5, 4, 3. So we can see it's actually peaking at about 464 kilohertz. Now, it doesn't really make much difference except that it seems my medium wave is off by a few kilohertz. So I don't want to really adjust do the RF alignment on this, because these coils seem to be all clogged up and it doesn't really make that much difference. In fact, it makes no difference at all when you've got one AM station in Madeira and everybody knows more or less where it is, or the few people that listen to it know more or less where it is. What I'm going to do is actually peak it to 460. So what I do now, it's at 464. I'm going to move it down to 460, which I believe is where it should be. And I'm going to adjust one of the coils of the second IF transformer and try and peak that. Other way. Oh, not much difference there. Let's go to the other coil in the second IF transformer. Got a bit more out of that. Now the first IF transformer, one of the coils, that's peaked there, and the other coil, yes, that's peaked quite nicely there. Now I've obviously got to go do them all again just to adjust it further. There you see that, the second one. Go to the second IF transformer and do those again. Not much there. Now I'm peaking this with a pretty high amplitude signal, and what happens then is, you see, we're getting 1.58 volts peak, RMS over there. That's far too high to do your IF adjustment. I just wanted to get a ballpark first. So what I'm going to do now is reduce the amplitude of that signal by adding another 6 dB drop. That's more like it. So we should make this signal as small as possible. Hang on. That's still discernible as a sine wave. Yeah, it's pretty weak. Let's try that. That's more like it. Now, if we adjust it there, we're not getting the effect of the AGC coming in. In fact, I can probably give it just a bit more. That's 12 dB attenuation. Let's make it, that's 24 dB. Let's make it there. Okay, that's better. So I'll adjust the peaking there again, see if we can get an improvement. I'm looking at the VRMS value there. This is a lot easier actually if you use a analog meter. That's about right. That was pretty much peaked. I think they're all pretty much peaked. Didn't make much difference whether we have a strong signal or a weak signal. It's probably still weak enough that the AGC didn't really set in. Okay, now we've peaked this to 460 kilohertz, which I believe is the IF frequency. Now, does it make any difference? Not really. What you're actually doing here is you're just choosing a particular IF frequency and tuning the IF transformers for that particular frequency. And now we've done it for 460 kilohertz. So that's a quick tuning. Now there's a lot of videos on the web on how to do the alignments. A lot more detail. I've done a few with a lot more detail. I'm sure you can go and look at that if you want more information. But that's it. This thing is aligned. So with that part out of the way, with the radio working perfectly, we come to the part that obviously needs to be done, and that was the final cleaning. Now, you probably have noticed while I'm filming this that a few changes have happened. I replaced the power cord for a 3-wire cord so that I can get a proper chassis ground, make it safer. The other one was just a 2-wire. I've also done all the remaining cleaning of the chassis without going and getting too aggressive so that we don't create more rust in the future. These cans actually come out very well because they're so easy to remove, and I did remove them to check the circuitry inside, that I could actually polish them outside, and the result is pretty nice. So that was done, and then of course the knobs in the front. Now if you recall, I said maybe that's a brass in the front there. That's not brass. That is supposed to be like that. I couldn't get it. I was polishing it like crazy and I couldn't get any joy. So I think it's meant to be like that. It's sort of a browny gold stained front. Now the rings I actually filled in with gold paint. Those were definitely painted, and I scraped out the old paint, and then with some water-based acrylic paint, you fill in the ridges, the groove, and you scrape out the remainder. It takes quite a bit of work, but it looks nice. The faceplate was just basically clean the dust off very carefully. Same with this knob over here. And then the piano keys, well, everything has to be properly cleaned, polished. Nothing special, but they do look great. And then of course things like the pulleys get oiled, lubricated. Everything that's moving, you give it a bit of lubrication, makes all the difference. And the result is one to make me happy. And so we have radio back. We've got ourselves the radio that this is supposed to be. Well, all right. Now comes the next stage. The cabinet, which if you know me, you'll know that's one of my least favorite parts. But the cabinet needs fixing, needs polishing, cleaning, derusting of screws and all that jazz. And then the final section, which is the final task on this particular one, which is to add a Bluetooth receiver to it. And I'll go through how I do that. I've done a video on that, but there's another method I use as well. So that's what we're going to carry on with.